Just like any mathematics question, indeed in sciences, the key is always in practice. And so here we are with more questions involving indices, varying levels of difficulty. However, the same principles always apply. So watch till the end, and I promise you after this, you'll be much more better at indices. But always remember, the key is practice. And with that, say welcome to Tutor-E's Chemistry Hub. We will do our best with chemistry and mathematics, making them as simple as possible. Now we have a question. It says the square root of 8 squared times 4 raised to the power n plus 1 divided by 2 raised to the power n times 16. The question simply says simplify. Now if you remember the first rule we spoke about, whenever you are multiplying index numbers, the numbers need to have the same base. So in other words, 8 squared times 4 raised to the power n plus 1, the rules of indices will not apply at this time because they don't have the same base. 2 raised to the power 2n times 16, same thing happens. The rules of indices will not apply because they do not have the same base. So what do? We check all the numbers. Is it possible to make them the same base? If it is possible, then we do so, and then we can have our answer. So first thing first, this is almost like board mass, although we don't have a bracket, but still, everything we have here is inside the square root. So we are not going to be using the square root until we are done solving everything inside the square root. So we can make all of them have the same base. How? We can make them have a base of 2. And how do you do that? Well, it's pretty simple. Just take that 2, use it to divide each of the numbers. An example, when 2 divides 8, 2 divided 8 is 4, 2 divided 4 is 2, 2 divided 2 is 1. 2 divided 8 3 times, it therefore means that 8 is 2 raised to the power of 3. So I simply come here, I'll be taking out 8 and I'll be putting 2 raised to the power of 3. Now remember, there was a raised to the power 2 at the very beginning, so that stays there. So it just means that this 2 raised to the power 3 is actually 8. Times 4, same thing happens. We don't need to waste time with this. You can see that 4 started from here, and 2 divided 4 2 times. So simply say 4 is the same thing as 2 raised to the power 2. Again, there was a power there before. That means we need to use a bracket, and the power will be outside, n plus 1. Divided by 2 is already at the lowest base, so it remains 2 raised to the power 2n times 16. Again, can be made a base of 2. So we simply divide. 2 divided 16 is 8. 2 divided 8 is 4. 2 divided 4 is 2. 2 divided 2 is 1. 2 divided 16 4 times. So that means 16 is 2 raised to the power of 4. Now you can see they are all the same base. Now it is looking like the law of indices can apply. So again, until we are done solving everything inside the square root, we will not touch the square root. So now what happens? Remember one of the laws of indices. Again, if you haven't watched the video, check it out. That is the very first part of the series on indices. Whenever you have a bracket, the power outside multiplies the power inside the bracket. In other words, we'll be having 2 times 3. So we'll be having 2 raised to the power of 6. Times, same thing happens here. The power outside multiplies the power inside. Now you remember this 2 multiplies n. The 2 also need to multiply 1. So in most cases, what I like to do, whenever I have 2 terms like this outside, I also use a bracket. So just in case, you can simply do something like this to show that 2 will multiply n and 2 will also multiply plus 1. 2 times n. So first of all, let's have our base of 2. 2 times n is 2n plus 2 times 1 is 2. all over, we have 2 raised to the power 2n times 2 raised to the power 4. Now our work is becoming clearer and easier. Now again, what do you observe? Now you have the same base. You can simply go on and solve using the law of indices. Again, we are not done with what is inside the square root, so we still maintain our square root. Now we are going to solve our numerator first. 2, the same base, you can pick one since you are multiplying. The first power is 6, and then the next power, because you are multiplying, obviously you are going to add. The next power is 2n plus 2. Now, you can see I use the bracket here. I like to use it. Whenever it is plus, it will not affect your answers. But whenever it is minus, it affects your answers. So just to maintain uniformity, I use plus all through. Whenever you have two terms after a sign, always use a bracket. Plus may not affect, but minus will do so. So to ensure you do not forget, always learn to use a bracket. Divided by, you have 2 raised to the power 2n times, means you are going to be adding, and then you have 4. Now you can see this is just a single term, so I don't need to use a bracket in this case. But whenever it is more than one term, always use a bracket. Plus will not affect, but minus will definitely do so. So now we can go on. We have 2 raised to the power 6. Now you can open the bracket using what is in front of the bracket, which is plus. Plus times 2n is plus 2n. And plus times plus 2, plus times plus is still plus. Divided by 2 raised to the power of 2n and 4 cannot be added because they are not like terms. So it remains 2n plus 4. We are gradually getting towards the end. Now, again, if you observe 6 and 2n, they are not like terms, but 6 and 2, they are like terms. So 6 plus 2 is 8. So you have 2 raised to the power 8 plus 2n divided by 2 raised to the power 2n plus 4. We go further. Let me take this out. We are not done solving what is inside the square root, so we don't touch the square root yet. We go further. Now you have the same base again, so you simply pick one. Again, we maintain our square roots. So now you can pick one base. The power at the top, 8 plus 2n. We subtract the one at the bottom. You can see now the purpose of the brackets. Minus the powers below, 2n plus 4. So now we are going to be having 2 as our base, 8 plus 2n, minus times 2n gives us minus 2n, and then minus times plus 4 gives us minus 4. You can see if you do not use a bracket here, you just be having 2 minus 2n plus 4. Automatically your answer changes and it becomes wrong. So always remember to use a bracket. Whether plus or minus, use a bracket. When you expand the bracket, the actual values will come out. So we go on. We have the square root of, again, our like terms, 2n minus 2n. That means 2n minus 2n is gone. And then we have just 8 minus 4 left. 8 minus 4, that gives us 4. So now we can use our square roots. And if you remember, we have a principle that says a raised to the power 1 over n equals the nth root of a. What does that mean? Whenever you have a root, it simply means that that root was actually an index as a power. A fractional index actually. So what that means is that if we are having the square root of 2 raised to the power 4, it means that this square root was actually a fraction as a power 2, because it's square root, That was the denominator. We have a raised to power 1 over 2. That will give us the square root of a. You can see the square roots meant 2 was a denominator in the power. So that means you're going to be having 2 raised to power 4. Square root means 2 becomes a denominator in the power divided by 2. 2 divided 4 is 2, so we have 2 raised to power 2. So our answer is simply 4. So you can see the law of indices goes both ways. It is all about you learning and knowing how to manipulate, when to use which particular one. And that is the concept. Alright, so look at the second example, which is quite similar. So you can practically pause the video at this point and attempt this. Again, if you observe, the bases are not the same. So what's the first step? Make the bases the same. 81 and 27, you can make them have a base of 3. Even if you don't know this before, you can simply test it out. How do you test it out? Divide by 3. If 3 is able to divide all through, that means you can make them a base of 3. But if 3 cannot divide all through, then you cannot make them a base of 3. An example is the earlier one we had 8. If you wanted to make it a base of 4, 4 divided 8 is 2. 4 can no longer divide. That means you cannot make 8 have a base of 4. At least it won't be a whole number anyways. Alright, so we have 2 raised to power n minus 1. That's the lowest it can be. 3 divided 27 is 9. 3 divided 9 is 3. 3 divided 3 is 1. 3 divided 3 times. So we'll be having 3 raised to power 3 to be in a bracket because you only turn 27 to 3 raised to power 3. But the initial power, n minus 1, because it's 2 terms, we use a bracket. N plus 1 actually. Divided by 81. Can it be made a base of 3? Simply check it out. 3 divided 81 is 27. 3 divided 27 is 9. 3 divided 9 is 3. 3 divided 3 is 1. 3 divided 4 times. That means 81 is 3 raised to power 4. The power that was there originally, we leave it there. Alright, so now that they're the same base, all we simply have to do is, let me take all this out. We no longer need them. Alright, so now that they're the same base, first of all, let us expand our brackets. So we still have 3 raised to power n minus 1 times power outside multiplies the power inside. So you have 3 times n is 3n plus 3 times 1 is 3 divided by 3 raised to power 4 times n gives us 4n. Now in this case, a faster way you can do it is, since they are all the same base, just pick one base. Whenever you have times, it becomes plus. Whenever you have minus, whenever you have divide, it becomes minus. We can do it that way if you want to be faster, or you can take it step by step. I'll solve both ways just so you can see. Irrespective, you'll be having the same answer. So let us have the numerator first, going by the slower method. So you have 3, pick one base, raised to power n minus 1. Because you are multiplying, that means you are going to add the powers. You have 2 terms, so use a bracket. You have 3n plus 3, all divided by 0 raised to power 4n. So you move on, like I said, plus does not change the values. So you're going to have 3 raised to power n minus 1, plus times 3n remains plus 3n, plus times plus 3 remains plus 3, divided by 3 raised to the power of 4n. So now our like terms, because they are a bit scattered, I will just reorganize them in this case. So you have 3 raised to power n and 3n, they go together. So you have n plus 3n, those are your like terms. And then you have minus 1 plus 3. You have to be careful when collecting like terms. Ensure their signs go with them. Plus goes with 3n and minus goes with 1. Divided by 3 raised to the power of 4n. And so we have n plus 3n, that's 4n, minus 1 plus 3, that's plus 2, divided by 3 raised to the power of 4n. And so, to get our final answer, you are dividing now, you pick one base. So you have 3 raised to the power 4n plus 2, dividing, you subtract, minus 4n. So our answer, 3, 4n minus 4n, that's 0, so n is gone, raised to power 2. And 3 raised to power 2 is 9. Alright, so like I said, if you wanted to be a bit faster, what could you have done? 3, 3, 3 is the same base, you just pick one. You don't take too much time with it. You have n minus 1 as the first power, times becomes plus, so you have plus, open brackets, 3n plus 3 times, you're adding this power, then divide means you're going to be subtracting the next power. Divide, so you have minus 4n. So this one takes out a whole lot of steps. So you have 3 raised to power n minus 1. With plus, the signs remain the same. So you have plus 3n plus 3 minus 4n. Collecting your like terms, you have 3 raised to power n plus 3n. 4n goes with its minus, minus 4n. And then you have minus 1 plus 3. So you have 3 raised to power n plus 3n is 4n. 4n minus 4n is 0. n is gone. Minus 1 plus 3, and you have 2, which equals 9. So I guess we can say or. So you either go through the slow burning process, get the same answer, or you can do this. Once you have the same base, collect one base and move all of them on. You could have done exactly the same thing here. As soon as you made them the same base right here, as soon as you made them the same base, 2, 2, 2, 2, pick one. 6 times means you are adding. The numerator, you add all the powers, and the denominator, you subtract all the powers, and you get exactly the same answer. So the choice is yours. You can attempt that and see if you get the same answer. If you cannot, let me know, and we'll walk through it. Alright, let's look at this one. 27 raised to the power 1 over 3 divided by 16 raised to the power 1 over 4. Now this looks complex, but it is not. All you simply have to do is, I'm going to solve them separately and then take it back there to get our answer. So here's what I'll do. We are going to solve 27 raised to the power 1 over 3. And then we are going to solve 16 raised to the power minus 1 over 4. 27 raised to the power 1 over 3 is the simplest or the easiest. Remember, whenever your power is a fraction, the denominator becomes a root. So it simply becomes the cube root of 27. Raised to the power 1 makes no difference, so we can leave that out. What is the cube root of 27? Which number multiplies itself 3 times to give you 27? We have done that earlier and we had 3. In other words, our numerator will be 3. Now for 16 raised to the power 1 over 4, minus 1 over 4 actually. Whenever your power is a minus, what's the first thing you do? Turn it upside down. Make it 1 over. If it was a fraction, turn upside down. But because it's not a fraction, just make it 1 over 16 raised to the power 1 over 4. So now you're having 1 over, you have a fractional power, the denominator becomes a root. That means you'll be having the 4th root of 16. What does that mean? Which number will multiply itself 4 times to give you 16? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. That means you'll be having 1 over 2. That's exactly what we needed. Solve them separately to make it clear for us. So that means 27 1 over 1 over 3 gave us 3. 16 raised to power minus 1 over 4 gave us 1 over 2. So we'll now be having over 1 over 2. So what does that mean? It means this is the same thing as 3 divided by 1 over 2. Whenever you have divide, what do? You switch it. So you'll be having 3 times, divide becomes times, switch the fraction, 2 goes up and 1 comes down, you have 2 over 1. So our answer, 3 times 2, 6 over 1, the same thing as 6. So there we have our answer. Alright, and finally for this video, again, worry not. I have more questions which I'll be solving in subsequent videos. If you have questions, you can bring them up and we'll solve them. The key is always practice. Now when you look at this, 3.2 squared minus 4.8 squared divided by 3.2 minus 4.8. Someone may look at this question and say, oh, this is difficult. Well, it depends on how you look at it, but this question is actually pretty very simple, right? First of all, they are not the same base. That's one. Even if they were the same base, you cannot use the law of indices here because the sign here is minus. So that has no business with the law of indices. But if you look at this question, you should be able to remember something that's called the difference of two squares. Now, I know most times we use this question when we are factorizing quadratic expressions or equations. Yes. However, most mathematics concepts are not restricted to one part of mathematics. They can be used in other parts of mathematics. And this is one of those cases. What does that simply say? Whenever you have a squared minus b squared, the answer is the same thing as a plus b multiplied by a minus b. That is the concept of the difference of two squares. Whenever you are subtracting two squares, the answer is the same thing as add the two bases and subtract the two bases, then multiply your answer. So now you're having 3.2 squared minus 4.8 squared. It simply means that that is the same thing as 3.2 squared plus 4.8, sorry, not squared, just the basis. Similarly, that is the same thing as 3.2 plus 4.8 multiplies 3.2 minus 4.8. Difference of two squares divided by 3.2 minus 4.8. Now what do you observe? What you have in the denominator is the same thing with one of the brackets. That simply means that they can cancel out. So what are you left with? 3.2 plus 4.8. And your answer, when you add this, should be having 8.0, which is the same thing as 8. You can decide to use a calculator, or you can decide to use the simple method, which you have been blessed with in difference of two squares. Alright, watch out for more videos, and remember, as always, like, share, and subscribe.